All right, welcome again to another one of Mr. Martin's math videos. This is a math video for British Columbia Math 9. We're in Chapter 6, Section 3, Solving Equation Notes. So we're going to be exploring more complex algebraic equations to solve. We're going to explore and model problems with linear equations involving unknowns on both sides, so variables on both sides. And we're going to, again, use multiple strategies to solve linear equations of unknowns on both sides. Okay, so now that we come to the last section in our chapter on solving algebra, there's nothing really new here, just more complicated equations that we've been dealing with so far. Today we'll study equations that have one of the following forms. Okay, the first situation is when you have variables on both sides of the equation and one constant, one number that isn't a variable. Okay. The next type of equation when we have variables on both sides of the equation and constants on both sides of the equations. All right, and the last one will be variable on both sides of equations and on also constants and brackets on both sides of the equation. So how are we going to handle those? All right. So the central concept that will help us solve these types of problems is variables on one side, constants on the other. Okay, if we are going to, one of the goals of algebra is to isolate the variable on one side of the equal sign. If we have variables on both sides of the equal sign, we have to bring those variables to the same side first, and then adding like terms or combining like terms, and then isolate the variable. So let's see what that looks like. Let's try a couple of examples here. All right, so in this situation, I have 6x plus 4 is equal to 7x minus 88. So I have variables on both sides of my equal side here. So in order for me to be able to isolate the variable, which is x, I need to bring the 6x and the 7x on the same side of the equal sign. Okay? And now you can choose to bring the 7x over to the left side or the 6x over to the right side. It doesn't matter which side you choose, as long as whatever you do to one side of the equation, you do to the other side of the equation. Now, for me personally, I always bring the variable with the smaller coefficient over to the side where the variable with the larger coefficient is. Okay, so that means I'm going to be bringing 6x over. Now here, also another point to kind of note here, I know that it's 6 times x, but at this stage, I'm not trying to separate the 6 and the x. I'm trying to bring 6x all together over to the right side of my equation. Okay, so for me to do that, I'm going to subtract it, okay, because this is positive 6x, so I'm going to subtract 6x on both sides. Okay, and again, based on what this is telling me, variables on one side, so this is bringing the 6x over should do that, and I want to bring the constants all on the other side. So if I'm bringing my variables over to the right side, okay, this is my variable side, then the other side, because this is going to cancel out, right? This is positive 6x minus 6x is equal to 0, so they cancel out. Okay, then the left side is my constant side. Okay, I'm only going to write these kind of words on top of my equation once, but just because we're learning. So that means that 4 is going to stay here, and I'm going to bring over the 88. So because it's minus 88, I'm going to plus 88 on both sides, plus 88, plus 88. Okay, I'm going to do this all in one step. All right, so that's plus 88. Minus 88 plus 88 equals 0. That cancels out. Okay, and that's going to leave me with 7x minus 6x, because those are like terms, I can combine those. 7x minus 6x is equal to 1x, or just x. Okay, and then is equal to 4 plus 88, which is 92. And that's my final answer. Okay, let's try a couple other ones here. Okay, let's try this one here. This one, actually, no, wait. Yeah, let's try this one here. This one's got a bracket inside. Now, we did talk about last set of notes. Sometimes it makes sense to divide the side with the bracket by the number like 25 in this case. But in this case, 25 doesn't go into 10 at all. And so I would just end up with a fraction. And so I don't want to do that. It doesn't make sense to do that in this situation. So what I'm going to do is I'm going to distribute first the 25 into my brackets. So that's going to give me 10d still on the left side is equal to 25d minus, and then this is 25 times 30, which is 25 times 30, it seems 750 minus 750. Okay, 25 times d and 25 times negative 30, that's what I get. Okay, now I have variables on both sides of the equation. I'm going to bring all the variables to the side that has the largest coefficient in front of the variable. So 25 is greater than 10. So I'm going to bring the 10 over. So I'm going to subtract 10d on both sides. When you're subtracting 10d, okay, you're bringing the 10 and the d over. If I were just to divide by 10, I would be leaving the d on the left side, and so I still wouldn't have all the variables on the same side. So I need to subtract to bring both the 10 and the d over to the right side. Okay? So I've decided that the right side of my equation is for my variables. That means my left side of the equation is going to be for my constants. So at the same time, I'm going to add plus 750 to both sides of my equation, right? This is the center line of my equation. Now what that's going to give me, there's a lot of things going on here. This is going to cancel out here. Now I get 25d minus 10d is 15d is equal to 750. All right? Then from there, I divide both sides by 15, and I get d is equal to 50. That would be your final answer there. Okay, so that strategy about dividing what we were talking about at the beginning of this question is not going to be really applicable in this set of notes. When problems get more complicated, that strategy is less likely to work. So you'll be using the distribution, the distributive property here for most of these questions that deal with brackets. Okay. Let's try another one. These are just, now we're just working through these quickly, okay? And you'll get a chance to practice a few of these as well, okay? Again, here, dividing by 4 on both sides wouldn't make sense because I'd end up with 2 fractions. And so I'm going to distribute the 4 into my bracket. So 4 times 5n is 20n. And 4 times negative 7 is negative, what was it, 28? Is equal to 10n plus 2. Okay? And again, now the left side of my equation is the one that has the variable with the larger coefficient. So I'm going to bring the 10n over to the left side. So I'm going to do minus 10 on both sides. Minus 10n on both sides. Okay, and that's going to cancel out. Plus 10n minus 10n is 0. That cancels it out. And because the left side is my side for the variables, my right side of the equation is going to be my side for the constant. So that means I need to get rid of the 28 here and move it over to this side here. Okay, that is going to, so lots of things cancel out. What I'm left with is this and this, right? And so this is going to leave me with 20n minus 10n is 10n is equal to 30. Last step, divide by 10, divide by 10. And I end up with n is equal to 3. Okay? One more example here. Okay? In this example, it does make sense for me to divide both sides here because 3 goes into 9 nicely. So I can use this step right off the bat, or I can just distribute and just kind of stay consistent. So I'm just going to distribute and stay consistent. But if you wanted to just divide both sides here by 3, you could, and that would mean you wouldn't have to just, I guess we could try it. Let's do that. So I'm going to divide both sides here by 3. Because 3 goes nicely into 9, I can do this. But only because of that reason. Okay, you don't want to do it if that's not the case. So the 3's cancel out here, so that means I get 3k minus 9 without any brackets on the right side. And then on the left side, 9 divided by 3 is 3 bracket 11 minus k. Okay. In this situation, since we're dividing by, I'll distribute the 3 here into my brackets. So 3 times 11 is 33. 3 times negative k is negative 3k is equal to 3k minus 9. Okay. Now here, you also want your variable to have a positive coefficient, not a negative coefficient. So if I were to minus 3k and bring this 3k over to the left side, I would end up with a negative 6k. You don't want a negative coefficient necessarily in front of your k value. You typically want a positive one. You're not going to get it wrong. You'll still get the right answer. It's just a simpler, less likely for you to get tripped up in the negatives, positives. So what I'm going to be doing then, for that reason, is I'm going to seek to bring this negative 3k over to the right side. Okay, so that's what I'm going to do. And I'm going to do that because it's minus 3k. I'm going to add 3k to both sides. Okay? So that's going to cancel out the k's, negative 3k on this side. All right? So my right-hand side is my variable side. That means my left-hand side needs to be the constant. So that means I need to move this negative 9 over to the left side. So this is negative 9, so I'm going to have plus 9 on both sides. Plus 9 on both sides. That cancels out. So what I'm left with is this. 3k plus 3k is 6k. And this, 33 plus 9, which is 42. And then last step, divide by 6, divided by 6. K is equal to 7. Okay? So, I know I went pretty fast there on some of these questions. If you need to, pause, rewatch those videos, make sure you understand what I'm doing. Key here, variables on one side, constants on the other. So here, again, like I talked about over here in the very first question, I'm not seeking to separate the 6 from the x when I move it over to the right side. I want to move the 6 and the x together. So I don't divide by 6, I subtract 6x on both sides. That will move the variable. And then you combine like terms on the other side here. Then you do the same thing, moving the constants to the opposite side. And then combine like terms. In this case, we got our answer right away. In other questions here, we had to do one more step of dividing. But in the end, you still get the same answer. Okay? Your turn. These 2 questions here, go ahead and pause the video, give it a shot, and then we'll unpause the video and we'll do it together. All right? Go. All right, hopefully these questions went well for you. Let's dive in here. Okay, so I have negative 69 minus 2x equals 29 plus 5x. So I want all my x variables on the same side. And 5x is greater than negative 2x. So I'm going to bring my variables to the right. So I'm going to do that because it's minus 2x, I'm going to add 2x to both sides, plus 2x plus 2x. Okay? Minus 2x plus 2x is equal to 0, so they cancel out. Okay, I'll add a step if you want to. Well, just to show, because maybe I was going too fast. So minus 69 is equal to 29 plus 7x. Okay, combining these like terms here. Okay, and then I bring my constants to the left side. So I would minus 29 on both sides. And then these cancel out, and I end up with 7x is equal to negative 98. Okay? And so here, this is what and before when I was explaining, I did this step right at the beginning. I just did, and I need to move this constant over to the other side, so I'm minus 29 right at the beginning. Okay? All in one step. But here this is what it looks like if you break it into 2 steps. Okay, first you move the variables, then you move the constants, or you can do both steps at once and go straight to here. Okay, either way, you're going to get the right answer. All right, divide by 7, divide by 7. X is equal to negative 98 divided by 7 is negative 14. And that's your answer. Okay, again, doesn't matter which side the variable on, left or right. Just make sure you're isolating the variable on one side and the constant on the other. Let's try this question. Here, it doesn't make sense to divide both sides, for example, here by negative 7, because negative 7 does not go well into 13. So I'm not going to use that strategy. I'm going to distribute. All right, so negative 7 times 1 is negative 7. Negative 7 times negative 4m is positive 28m. All right, watch those negatives and positives, right? Negative 7 times negative 4m is positive 28m. Next is 13 times 2m is 26m, and then 13 times negative 3 is negative 39. Okay. My larger coefficient in front of the variable is over here. So I'm going to bring the 26m over to the left side by subtracting 26m on both sides. That's going to cancel this out here. All right. So because my left-hand side is my side with the variable, I'm going to bring the constant to the right-hand side. So that negative 7, I'm going to add 7 to both sides. And that's going to cancel out that 7. I'm left with 28m minus 26m, which is 2m, is equal to negative 39 plus 7, which is negative 32. And last step, divide both sides by 2. To isolate the m is negative 16. And that would be your final answer. All right, hopefully this video is helpful for you so far. All right, that's just the first page of our notes. Let's keep going. Okay, sometimes you'll face questions that even look like this. Okay, even a little tougher, a couple more steps, but it's the same idea here. In order to get rid of the brackets, you're using the distributive property. And here you'll notice that there's just no way that you can divide both sides and get rid of the brackets. Like that strategy we used last set of notes. It's just not very applicable once we get into more complex questions. So we just wanted to use distribution, okay, the distributive property. So that's what we're going to do. 8 times 4u is 32u. And then 8 times negative 1 is negative 8. Okay, and that is beside negative 12u is equal to 11 times 2u, which is 22u, and 11 times negative 6, which is negative 66. All right, so now we've gotten rid of our brackets. Now I'm going to combine like terms on the one side of the equation. Okay, so this and this are like terms. So on this side of the equation, I'm going to get 32u minus 12u is going to give me 20u minus 8 is equal to 22u minus 66. All right. Now here, with the variables with the largest coefficient is 22u, so I'm going to bring that 20u over to the right side. So I'm going to subtract 20u on both sides. All right. 20u minus 20u is equal to 0. They cancel out. That means, so my variable is going to be on the right. Okay. The 22u minus 20u is going to give me 2u. Okay. That means my constant needs to be on the left-hand side. So I'm going to add 66 to both sides. And this cancels out. Negative 66 plus 66 equals 0. Negative 8 plus 66 is 58. And then divide both sides by 2 to isolate the u variable. U is equal to, what is that, 29? All right, and that is your final answer. So don't be scared of taking the steps that it needs. Combine the like terms on each side of the equations first before you start swapping like terms left to right across the equal sign. And that will help you stay on top of things and keep track of all of the numbers that you're dealing with. Okay, we're going to do a practice assignment based on this work. So far, yeah, that's it for, sorry. That is it for today. Like I said, I'm not gonna do a long video. We're gonna split this section into 2 parts. So the first part I want you just to get used to is just bringing your variables to one side when you have variables on 2 sides of the equation. Okay, that's the crux. And again, remember, variables on one side, constants on the other. So the homework assignment for this first half of 6.3, okay, is what I talked about with you guys today in class. This it's in your OneNote. This assignment right here, you choose any 15 in this following worksheet. And however, the 8 that are highlighted need to be part of those 15. So you have to do the 8 that are highlighted here, and then the other 7 are ones of your choice. So you can go through and pick any other 7 that you see on the worksheet. Okay, and that's going to be due after the weekend on Monday. Have a great weekend. Hopefully this video has been helpful to you, and we'll see you next time. Goodbye.